Hello, this video is to help people trying to figure out how to do age word problems in Algebra 1. If you're in my class, the last one we do is going to be one of the ones from the homework. I didn't want to do them all because I wanted you to be able to do some on your own. So here, this first one, Adam is 20 years younger than Brian. In 2 years, Brian will be twice as old as Adam. How old are they now? Before you get into the words of the problem, the key here is identifying what kind of, I call them time zones you're dealing with. Sometimes there's two, sometimes there's more than two. In this case, we're talking about now because of this word is, and then we're talking about 2 years from now because of this phrase in 2 years. And what I like to do, and I think what will make it real easy for you, is if you set up your variable declaration in two time zones in this case. So what I'm going to say is we have Adam and we have Brian. And I'm going to set up a little variable chart here, variable expression chart. And we have now, and we have 2 years from now. Geez, that's very messy. We'll be okay. Okay, so what is Adam's age now? We don't know. So how about a variable? A, what is Brian's age now? We don't know. How about a variable? B, 2 years from now. 2 years from now, I'm going to add 2 to my age. So Adam will be A plus 2. So whatever he was, plus 2 more years. Same thing with Brian. So now I'm going to reread the problem, and each sentence is going to be an equation. So we're going to set up a system here. So Adam, now I'm going to directly translate. Adam, which we know is A. So Adam is 20 years younger. That means something minus 20. 20 years younger than Brian, which is B, because in this first sentence, we're talking about the now time zone. All right, the next sentence, so there's our first equation. Our next sentence, we have in 2 years. So now we're talking about everything in this right side column. So we're going to ignore this now. A and B no longer exist. Now we have A plus 2 and B plus 2. In 2 years, Brian will be. Will be is the future tense version of is. So that's our equal sign. So Brian equals. So Brian is B plus 2. So Brian equals twice as old as Adam. So twice means 2 times. And Adam, remember, we're still in this column. So Adam's A plus 2 right now. Okay. I should mention that a prerequisite to solving these types of problems would be knowing how to solve systems of equations using elimination, substitution, and possibly graphing. If you don't know those things, you should go back and learn them before you start on these word problems. Okay, so it looks like this is set up very nicely for a substitution because we have a first equation is already solved for one of the variables. So I'm going to write the second equation, b plus 2 equals 2 times. Now, instead of writing A, I'm going to substitute in that B minus 20. So we have B minus 20 and then plus, well, I guess that should be in red. Okay. B minus 20 plus 2. All right, so we basically wrote that second equation, except instead of writing A, we wrote B minus 20. Now I'm going to clean that up, simplify. I'm going to use the distributive property. There's a couple different orders I could do this in. I'll just distribute the 2 to the 2. All right, so now, again, there's lots of different methods to fixing this up. But the first thing I'm going to do is I'm going to subtract 2b because why not? I like to have a variable on the left side. That's going to make it negative, but that's all right. I'll deal with that later. And I can combine these right now. Negative 40 plus 4 is negative 36. Now I'm going to subtract 2 to get that b isolated all by itself. Now we have negative b equals negative 38. Of course, if the opposite of b is the opposite of 38, b must be exactly 38. You can also just multiply both sides by negative 1 there. All right, now I'm going to go back. I know how old Brian is now. B is 38, so I think that's 38 right here. I always say I think because I don't know until I double check with the words of the problem. You'll see in a moment. If B is 38, 38 minus 20 is 18. So I think Adam is 18 now, and then Brian is 38, which means I think 2 years from now, Adam will be 20 and Brian will be 40. Okay, now I'm not done yet because now I'm going to reread the problem again every time I do this. So Adam is 20 years younger than Brian. Is that true? Yes. So now I feel pretty good about it. In 2 years, Brian will be twice as old as Adam. Yes. Now I know that I am correct because I've double checked my answers with the words of the problem. Now I'm going to reread the question. How old are they now? Brian is 38. Adam is 18. Done. Next problem. Carmen is 12 years older than David. 5 years ago, the sum of their ages was blah, blah, blah. So the first time I read through the problem, I'm looking for time zones. So we have Carmen. We have David. The time zones is, so we're talking about now, and we're talking about 5 years ago. 5 years ago. So there's our chart here. Once again, I usually write the variables, the C and the D or whatever variables I'm using in the now column, unless there's a reason not to. In this case, I don't see a reason not to. So Carmen, we'll call her age C and David D. So 5 years ago, Carmen was C minus 5. I'm not even looking at the word problem right now. I'm just calling Carmen C, calling David D. I know that 5 years ago means we're going to subtract 5. This has nothing to do with the word problem at all. The only thing I got from the word problem were these headings. Carmen, David, now 5 years ago. Now I'm going to start reading the problem. Carmen is C equals 12 years older than David. So that's David plus 12 years. Second sentence, 5 years ago. So now we're in this column. Forget about C and D. That's not what we're dealing with right now. 5 years ago, the sum of their ages. Well, that's different. So we're going to add their ages. So we have to add those. C minus 5 plus D minus 5. The sum of their ages was, that's the past tense of is, so that's our equal sign, was 28. Okay. Once again, the first equation, which came from the first sentence, is isolated already. So I'm going to rewrite equation 2, but I'm going to substitute in D plus 12 for C. So equation 2, let's see, so we're going to do D plus 12 minus, I'm not going to have enough room. Okay, I'm going to move this down. Okay, let's go here. D plus 12 minus 5, so that's this part, plus D minus 5 equals 28. So I have two positive D's, so I'll just add those. And I have a 12 and a minus 5 and another minus 5. So essentially that's 12 minus 10, so that's plus 2 equals 28. Now notice that's different than the last one. The last one, the things were on different sides, and so I had to use inverse operations. Here they're on the same side, so I just go ahead and add and subtract them. Speaking of which, I'm going to now do inverse operations. We're going to subtract 2. So now we have 2D equals 26. So therefore, when I divide by 2, I'm going to get D equals 13. I'm running out of room here. Let's see if I can deal with that. D equals 13. Now I'm going to go back to maybe this equation here. I could use either one, but this one's nice and easy. So 13 plus 12, no problem. C must equal 25. Once again, I think that C is 25, and I think that D is 13. Therefore, 5 years ago, Carmen must have been 20, and David would have been 8. Now I'm going to reread the words of the problem, see if what I believe to be correct is true. Carmen is 12 years older than David. That is true. 5 years ago, the sum of their ages was 28. Certainly, that's true. So now I know I'm correct. How old are they now? Well, Carmen, let's do that in red. So Carmen is 25. David is 13. No problem. Okay, moving on. 5 years ago, Jerry was 2/3 as old as Jeff. Um, my recommendation is that you try this on your own, pause it, see if you can do it, at least set up the variable declarations. That's the key, remember? Here we go. So 5 years ago, so the two time zones and the people. So we have Jerry and Jeff. That's annoying because they're both J, so we'll have to figure out a different variable, no big deal. And we have 5 years ago and 10 years from now. So what I do just to keep it easier, and you don't have to do this, but I totally recommend it, there is no now time zone in this word problem. And so I recommend, okay, there is, in fact. Actually, the question is that. So we're going to have a now, then we're going to have 5 years ago, and then we're going to have 10 years from now. Okay. Even if there isn't a now, it's always good to start with a now because it makes the rest easier. We'll call Jerry J, and we'll call Jeff F. How about that? And 5 years ago, this would be J minus 5, and this is F minus 5. And 10 years from now would be J plus 10 and F plus 10. So 5 years ago, so now we're in this middle column, Jerry, so J minus 5, that's equals, 2/3 as old as Jeff, that's F minus 5. Now remember, 2/3 has to be multiplied to all of Jeff, not just the F part. 10 years from now, so I guess he is 5 years ago, Jerry. I think that's referring to Jerry. 10 years from now, yeah, because Jeff. Okay, so 10 years from now, Jerry, that's J plus 10, will be, that's the is, 5/6 as old as Jeff, which is F plus 10, remember. So now we have our two equations. This is a little more of a pain because we have fractions, but honestly, it's not that big of a deal. If we multiply equation 1 by 3, and we multiply equation 2 by 6, we can deal with that pretty easily. So let's multiply equation 1 by 3. So remember, everything's going to get multiplied by 3. And when I say everything to this right side, that's kind of could possibly be confusing because it actually only really happens to the fraction. So on the left side here of equation 1, we're going to have 3j minus 15. And on the right side, the 3's cancel out, right? And leave us with 2. I guess I'll do this in 2 steps so it's not super confusing. The 3 just canceled out the fraction there. And equation 2, we're going to multiply by 6 because there was a 6 on the bottom of that. So let's get rid of that. Okay, so on the left side, we're going to end up with 6j plus 60. And on the right side, those 6's cancel each other out and leave us with 5 times f plus 10. Okay, I'm going to gather some room here. So I'm going to do distributive property on the right side of both of these. So that was equation 1, that was equation 2. So back to equation 1, we have 3j minus 15 equals 2f minus 10. And then equation 2, we're going to end up with 6j plus 60 equals 5f plus 50. Okay, now unlike the previous 2 problems, there is no variable that we're currently solved for. So this is going to take some extra manipulation. Not a big deal, but it could be a little bit of a pain. First thing I'm going to do is clean them up a little bit by combining like terms. So there's a minus 15 over here and a minus 10 over here. So if I add 15 to both sides, so back to equation 1, I'm going to add 15 to both sides, and that's going to give me something like 2f plus 5. All right, in equation 2, I'm going to guess I'll subtract 60 from both sides and end up with 6j equals 5f minus 10. So now they're set up almost perfectly for an elimination. If these both were 6s, or if they were opposites, if one of these was a -6 and one was a +6, it would work out pretty nicely for elimination. So let's do that. Let's make this top one a -6. We're just going to multiply the top by -2 everywhere. All right. So equation 1 is going to end up as -6j equals -4f minus 10. And then equation 2, we're just going to keep the same. And it looks like this. So when we add these together, we're going to get 0 equals f minus 20. And then if we add 20 to both sides, we're going to get 20 equals f, or f equals 20. Now, if we go back to, I don't know, one of these equations, maybe equation 1 right here, looks maybe like the easiest. So, so equation 1 is going to be 3j minus 15 equals 2 times, and now we know f is 20, so we're just going to replace that. So 3j minus 15 equals 2 times 15, so that's going to be 30. And then I'm going to add 15 to both sides, so I'm going to get 3j equals 45. And finally, we're going to divide both sides by 3 and figure out that j is 15. Okay, so now we think that's true. So we have f is 20 and j is 15, so I'm going to go way back up here. This is a nice problem. I like it. F is 20 and j is 15. Okay. That means 5 years ago we were at 10 and 15, and then 10 years from now we were at 25 and 30. All right, so let's reread the problem and see if everything worked. 5 years ago, Jerry was 2/3 as old as Jeff. That is true. That works right here. 10 years from now, he will be 5/6. Yeah, because if you divide that by 6, you get 5, and yeah, that works. 5/6. So 30 times 5/6 is 25. So that works. How old is each now? We're out of room, so I'm just going to circle the answer. This is their ages right now. All right, that was a fun one. Okay, moving on. This is the one from your homework if you were in my class. So here we go. Once again, we're talking about Joe and his daughter. So we have Joe, daughter. Not really reading the problem yet. Time zone, 6 years ago. 6 years from now. How old is Joe? So that's the now. So we're talking about now. We're talking about 6 years ago. 6 years from now. So lots going on. So we have now, 6 years ago, 6 years from now. Okay, so Joe is J, daughter is D. Notice I haven't even really read the problem yet. I've skimmed. I've looked for the 2 people that are involved and the time zones. That is it. I'm filling out this. I do not care what's in the problem yet. I'm just, if Joe is J now, he must be J minus 6 years ago. Has nothing to do with the problem at all. J plus 6, D plus 6. Okay, now I can read the problem for real. 6 years ago, so now we're in this column, Joe was, so we're talking about J minus 6. Was is the past tense of is. Joe was 2 years more, so that means plus 2. We're going to add 2 to something. 2 years more than 5 times as old as his daughter. So 5 times his daughter, which is that. That's equation 1. Equation 2, 6 years from now, so we're in this column. He will be, that's he is. So Joe, J plus 6 will be 11 years more. So something plus 11, twice as old as she will be. Twice as old as she will be. Okay? The key is all in the time zones, people. Well, this one, again, looks like it's going to be pretty nasty to clean up, but, no big deal. So let's just deal with equation 1 for a while here. So this is equation 1, equation 2. So I'm going to move over here. First thing I'm going to do is equation 1, I'm going to do the distributive property with that 5. So j minus 6 equals 5d minus 30 plus 2. Now I'm going to add 6 to both sides. J equals 5d. And now we have minus 30 plus 2 is already minus 28. And then we're going to add that 6, so it's minus 22. Well, that doesn't look too bad once you clean that up. Now equation 2, I'm going to first do that distributive property again. J plus 6 equals 2d plus 12 plus 11. I'm going to subtract 6 from both sides. And that 12 plus 11 already is 23, and then I'm going to take away 6 from that, which is going to be 17. Okay, that's not too bad. We can do a substitution. So I'm going to create some space here. That was a lot easier than the last one, I think will be, this will be a lot easier than the last one. So both of these j's, well, j is equal to j, so that means this stuff, 5d, minus 22 must be equal to 2d plus 17. So if I add 22 to both sides, I'll get 5d equals 39. And if I whoops, just kidding. All right, let's try that again. If I add 22 to both sides, I'm going to get 5d equals 2d plus 39. Now I'm going to subtract 2d from both sides, and we're going to get 3d equals 39. Those are compatible. That's great. If I divide both sides by 3, I get d equals 13. Now going back to something that looks not too bad, like equation 2 right here. We know that d is 13, so 13 times 2 is 26, plus 17 is, 36 plus 7, so 43. So we think j is 43. All right. So D 13, J 43. D 13, J 43. Now I'm going to 6 years ago means 37 and 7. 6 years from now means 49 and 19. Now I'm going to read the problem again. 6 years ago, that means we're in this middle column. Joe was 2 years more. Okay, so 2 years more than 5 times. Well, 5 times would be 35, and 2 years more than that is 37. So checks out for sentence 1. 6 years from now, we're in this column. He will be 11 years more than twice as old as she will be. Well, twice as old will be 38, and 11 more than that is 49. That's a check. How old is Joe is the question. So Joe is 43. Boom. All right, that was fun. Age problems.